Let's look at a few different types of examples of word problems. For example, a coffee manufacturer wants to market a new blend of coffee that sells for $3.90 per pound by mixing two coffees together that sell for $2.75 and $5 per pound respectively. What amounts of each coffee should be blended to obtain 100 pounds of the desired mixture? I think that the key to solving word problems like this is organizing your information, and I like to organize it in a table. So we'll have the coffee, we'll have the price per pound, we'll have the pounds, and the cost. So we've got coffee A, which is $2.75 a pound. We've got coffee B, which is $5 per pound. And we have a mixture, which is $3.90 per pound. And we know we want 100 pounds of the mixture. And the cost is found by multiplying the price per pound by the number of pounds. So that would be $3.90 times 100. Okay, so we know that the total number of pounds of the mixture is 100. But we don't know the individual pounds of coffee A and B. We can assign variable A to be the pounds of coffee A. And since the pounds of coffee A and B have to add up to 100, coffee B must be 100 minus X pounds. We can find the cost again by multiplying the price by the pounds. So for coffee A, we have $2.75 times X. And for coffee B, 5 times the quantity 100 minus X. Okay, so that's our organization. From here, we can set up an equation about costs. So 2.75X plus 5 times 100 minus X must equal the total cost, $3.90 times 100. Okay, we're going to solve this equation for X. Okay, if we distribute the 5 to the 100, we get 500. 5 times negative X is minus 5X. 390 times 100 is 390. Okay, let's combine our like terms on the left-hand side. Combining our x's, we get negative 2.25x plus 500 equals 390. Move the 500 to the right-hand side. So negative 2.25x equals negative 110. Divide both sides by negative 2.25. And x is about 48.89. It's 48.8 repeating, I believe. But here we'll round it just to make it easy and say 49 pounds of coffee A. So that was coffee A. And to find that number of pounds of coffee B, we'll do 100 minus 49, which is 51 pounds of coffee B. So this is an example of a mixture problem. Okay, let's look at another example. Example 2. A motorboat maintained a constant speed of 15 miles per hour relative to the water in going 10 miles upstream and then returning. The total time for the trip was 1.5 hours. Use this information to find the speed of the current. Okay, again, let's organize this information in a table. So I've got upstream journey and the downstream journey. And we need a rate, which is a speed. So up and then the time and then a distance. Rate times time equals distance. So upstream, we've got the 15 miles per hour that the motorboat is traveling, and upstream we're going against the current. So if C represents the speed of the current, we're going to do 15 minus C because the motorboat and the current are going in opposite directions. The current's going to slow the motorboat down. Downstream then will be the opposite. Current and motorboat are going in the same direction. So the rate downstream is 15 plus C. Okay, we know that the distance both ways, because upstream and downstream we're traveling the same distance, is 10 miles. And then rate times time equals distance. So time equals distance over rate. So for upstream, distance over rate is 10 over 15 minus C. And for downstream, It's 10 over 15 plus c. Okay, so that's our information. Now let's set up our equation. We know that the total journey was 1.5 hours. So the time it takes to go upstream plus the time it takes to go downstream needs to equal 1.5 hours. So time upstream is 10 over 15 minus c, plus time downstream is 10 over 15 plus c, and that adds to equal 1.5. Okay, now we just need to solve this equation for c. So I'm going to solve this by getting the left side with a common denominator, because we need a common denominator to add fractions. So my common denominator is going to be 15 plus c times 15 minus c. So I need to multiply the first term by 15 plus c over 15 plus c, and the second term by 15 minus c over 15 minus c. So our denominator is the product of 15 plus c and 15 minus c. My numerator for my first term is 10 times 15 plus c. And for my second fraction, it's the same denominator. And here my numerator is 10 times 15 minus c. And my right-hand side is still 1.5. Okay, we got a common denominator. Let's get everything or distribute everything and combine into one fraction. So if I distribute, I get 10 times 15 is 150, plus 10 times c is 10c, plus 10 times 15 is 150, plus 10 times negative c is minus 10c, and my denominator, if I FOIL that, is 225 minus c squared, and that equals 1.5. Okay, our 10c's cancel out, and our equation becomes 150 plus 150 is 300 over 225 minus c squared, and that still equals 1.5. Okay, let's solve this equation by multiplying both sides by 225 minus c squared on the left and on the right. So on the left side, the 225 minus c squares cancel out, and I'm left with 300. On the right side, let's distribute. 1.5 times 225 is 337.5. 1.5 times negative c squared is negative 1.5 c squared. Okay, so we're almost there. I'm going to rearrange it so my c squared's on the left side. I have positive 1.5 c squared, and I move the 300 to the right-hand side. So 337.5 minus 300 is 37.5. Now I'm going to divide both sides by 1.5. C squared is 25. Take the square root of both sides. C is plus or minus 5. But here it doesn't make sense to talk about current as going in negative speed. So the current, or the speed of the current, is 5 miles per hour. Okay, let's look at one more example. Oh, by the way, I call these rate times time equals distance problems. So one more example. Example 3. Patrice, by himself, can paint 4 rooms in 10 hours. If he hires April to help, they can do the same job together in 6 hours. If he lets April work alone, how long will it take her to paint 4 rooms? Again, let's organize our information. So we've got the person, the hours it takes to do a job, and the part of a job that can be done in 1 hour. So Patrice and April are our people, and then of course them working together. So Patrice takes 10 hours to do the job of painting 4 rooms. We don't know how long it takes April, so we can say it's X hours for April. And together they can paint 4 rooms in 6 hours. So the part of the job done in 1 hour is 1 divided by these hours. So for Patrice, in 1 hour, he can get 1/10 of the job done. For April, she can get 1/8 of the job done. 1x of the job done. And together they can get 1/6 of the job done. Okay, well, there's our organization. Let's write our equation. So the parts of the job done in 1 hour of each individual should add up to what it takes together. So 1/10 plus 1 over x equals 1 over 6. Okay, so let's look at our denominators. Our denominators are 10x and 6, and we're going to multiply the entire equation by 10 times x times 6, or 60x. Okay, distributing the 60x to all three terms, 60x times 1/10 is 6x. 60x times 1 over x is 60, and 60x times 1/6 equals 10x. Okay, so here's our equation. Let's move our 6x to the right-hand side. 60 equals 4x. Divide both sides by 4, and x equals 15. So we'll take April 15 hours to paint 4 rooms by herself. Okay, this is considered a constant rate problem.